Okay, a bit of mechanics today. So what is the difference between a normal reaction force and a reaction force, or a magnitude of a reaction force? You see this quite commonly in exam questions where sometimes you have to use a normal reaction force or a reaction force. So let's go through the difference today. By the way, before I go any further, I do have some free A-level maths revision guides on certain topics. Just go to the link in my bio, click that link, and you can get some free revision guides on different topics through the A-level maths syllabus. But anyway, what is the difference between a normal reaction and a magnitude of a reaction? I'm going to use my calculator to try and explain. And I don't mean plug in numbers into the calculator, I just mean use the calculator as an experiment. Now, what we can see here, there are no forces going to the left and there are no forces going to the right. We just have the calculator on the table. So we have a weight going down and we have a reaction force. And that reaction force goes in the opposite direction to the force of the weight going down. So that there is my calculator. We got the table there. Calculator's got a weight of mg newtons going down. And so we have this reaction force, which is going opposite to the weight in this direction here. And that is our reaction force here. We'll just call this R. Now this R literally is the magnitude of the reaction force, right? We have one force, one weight going down, and we have a reaction force. That value, whatever this value is here, that is the reaction force. That is the magnitude of the reaction force. Now it just so happens that this reaction force is perpendicular to the surface in which the reaction force came from. And we use the word in maths normal for two lines which are perpendicular, normal lines, which you would have seen in pure maths. So in this example, not only is this R the magnitude of the reaction force, it's also the normal reaction force too. So in this example, the normal reaction is the same as the magnitude of the reaction, right? Literally just that reaction force there. It's the only reaction force you have on the diagram from the table, and that is the magnitude of the reaction force. Now let's do a trickier example. So now we've got the calculator on a rough table. I'm going to push the calculator to the left a little bit. Now I'm not pushing hard enough, right? Because the friction, the maximum friction on the table is too big. My force going to the left from my finger is not big enough to supersede the maximum friction because the coefficient of friction is too big. I'm going to have to push it a bit harder, right? Here we go, push harder, harder, harder. Right, we're moving across now, right, move across. So in that situation, we had my finger here pushing to the left. So that was my finger force. We had a weight from the calculator going into the table. So these forces here, these two forces were the two action forces, right? The action of my finger and the action of the weight of the calculator going into the table. So that means we've got two reaction forces, right? So we've got the reaction force from the table going upwards to counteract the weight. And we've also got a reaction force over here going to the right to counteract my finger. So this second reaction force was the friction on the table. And this reaction force 1 was the normal reaction force from the surface. So as you can see, I've just written out here, normal reaction force of force 1 and friction for force 2. So we've got two reaction forces from the table. So what if we wanted to calculate the reaction force from the table, the actual magnitude of this reaction force involving both of these forces? Well, we have the friction going to the right. We have the normal reaction force, this NR force, normal reaction going upwards, right? So the magnitude of this reaction force is going to be the size of this force here. So in other words, using Pythagoras. So in this case, the magnitude of the reaction force from the table onto the calculator is the normal force squared plus the friction squared and then square rooted, obviously just using Pythagoras. You see this kind of thing quite a lot in moments questions, in rigid body questions, where you've got like a rod, a ladder hanging against a wall. You've got the normal reaction force perpendicular to the wall, right, coming straight to the right, straight to your right. And you've also got some friction as well. I'm trying to push the pen upwards, so the friction is going to be going downwards. So again, you do a Pythagoras calculation to get the magnitude of your reaction from the wall, but your normal reaction is just the force going straight to the right, perpendicular to this vertical wall. Now you could get examples where the pen or the rod is actually fixed to the wall. So not in the example I just showed you, my pen, where I put it against the wall. It wasn't fixed against the wall, right? In this example here, the pen could be actually fixed against the wall. In that case, you don't have friction because it's fixed against the wall. You just have some kind of vertical and horizontal forces. But again, the process for getting the normal reaction force is actually the same. You just do Pythagoras again. So I do hope that helps. I will go through another example with a fixed pen against the wall in one of my future videos. So do stay tuned for that.